All right, so this is just going over the Chapter 3 test review again, going through each parts of those solving those systems, and then the finding the feasible region in the second standard. Hopefully these are going to be a segment where we can start diving in and helping, if you're a little bit behind, catch up. But so the Chapter 3 test review, you have these three sets of lines. We call those systems, and you have to decide, okay, which one do I want to graph, which one do I want to do elimination, and which one do I want to do substitution. I chose to graph this last one. A couple of reasons. One, it's easy to get this into y equals mx plus b form for both of these, and then I can graph them. So just showing you that. Right here, I'm just subtracting 2x on both sides, and I get y equals negative 2x plus 5. Here is my y-intercept, so I go up 5. And then my slope is negative 2 over 1, so I go down 2 to the right 1, down 2 to the right 1. There I have my first line. The second one, I can subtract 3x first, and then divide by negative 3. So I get y, negative 3 divided by negative 3 is 1x. Well, just 1, and then the x comes along. And then 3 divided by negative 3 is negative 1. So my starting point is negative 1, and I'm going 1, up 1, over 1, up 1, over 1. Right here, this point is 2, 1. That's my intersection point. Right? So graphing is just graphing lines the classic way. You could use an XY chart if you really wanted to, and then graph the points. It's up to you. Second one is elimination. So I chose to do, the middle one is the elimination one. And here, my first step is I need to decide what I want to get rid of. My x's or my y's first, and I'm deciding I want to get rid of my y's first. To do so, I need to make sure that the coefficients in front of y are basically opposites of each other. So I'm multiplying this entire row by 3 so I can get 6y, and this entire row by 2 so I can get negative 6y. So now I have 21x plus 6y equals negative 3, 8x minus 6y equals negative 26. So when I add down, 21x plus 8x is 29x. 6y plus negative 6y, or 6y minus 6y, they cancel off. That's what we wanted. Negative 3 minus 26 is negative 29. Then I just solve for x, divide by 29 on both sides, and I get x equals negative 1. That's part of my intersection point, so the x part is negative 1. To find y, then, I just plug my x back into one of the equations. It does not matter which one. I just chose the 7x plus 2y equals negative 1 to plug back into. So I plug negative 1 in for x. We get negative 7 plus 2y equals negative 1. I add 7 over, and then I divide by 2 to get y equals 3. That's why my intersection point then is negative 1, 3. The last one is substitution. And what you have to do here is you have your two equations of lines. Decide which one you want to basically solve for x or solve for y. I chose to solve for x here, so I added y on both sides, and I get x equals y plus 9. Once you do that, I'm going to plug this y plus 9 in for x, because x equals that y plus 9, equal it for x here. So now y plus 9 is where x was. I substituted it in, hence the name. And then I distribute the 3, so I get 3y plus 27 plus 8y equals negative 6. Combine like terms, subtract this 27, it's right here. So I get 11y equals negative 33, divide by 11 on both sides, and I get y equals negative 3. To find x, you are just substituting what you know for y now, and for y here. So you get x equals y plus 9, so x equals negative 3 plus 9, and x equals 6. My intersection point is 6, negative 3. That's that first standard, along with can you now solve systems by graphing, again, but in inequalities. Same idea as the first one we did with graphing, right? Either make an xy chart or solve to get it to y is greater than or equal to mx plus b. Once you get a line, so say we did this line first, so we made the green line, dashed it because it's just a less than, you need to test. Test 0, 0. When you test 0, 0 into here, so you would get 0 is less than 6, which is true. I'm going to shade towards 0, 0. I'm going to shade this area that is containing 0, 0. And then I do the same thing for the black line. It's a solid line this time because of the greater than or equal to, the equal to part. and then I test again. So the test 0, 0. This time it came out false, so I'm going to shade away from 0, 0. Notice where there's overlap of green and black pen. That's your final solution. Part B of this test is all about, can you basically graph inequalities like this? What you're going to do is each part, there's 3 parts here. Y is less than or equal to 6. 4x minus 5y is less than or equal to 10. 2x plus y is greater than or equal to 2. You're going to graph each of those lines, either given to y equals mx plus b form or make xy charts. This one right here is just a horizontal line at 6. Right? That's what happens when you just have y is less than or equal to 6. Is just a line at 6. And then when you test 0, 0, you get 0 is less than or equal to 6. That's true, so you shade down. You graph each of these lines. Then you want to find what are the coordinates of the triangle, because basically you can get the shading where this triangle is overlapped. What are the coordinates? I got negative 2, 6, 10, 6, and then 1.4, negative 0.8. Once you do that, you find these 3 parts, and on your test you won't have a decimal at all. Then you have each intersection point, and you're going to plug the intersection point in for this profit function. Okay, so negative 2 goes in for x, 6 goes in for y, so you get 5 times negative 2 minus 2 times 6, which is negative 10 minus 12, so you get negative 22. Do that for each one. Your smallest number is your minimum, your largest number is your maximum. All right, so this is just going over the Chapter 3 unit test with the review. Hopefully then you can get caught up.